Okay, already we know that it's a common thing. If I thrown any object or maybe a stone into the sky, what will happen? It will be went into the sky. Okay, what will be happens? If I thrown a stone into the sky, what will be happens? It will be come back. It will be returns to it to the earth, right? I'm standing on the earth and I thrown a stone into the sky, then it will be come back, right? It will be reaches to the earth. It is common fact. We know that whether if a thrown a stone into the like a some with some angle into the projectile in the same in the path of projectile, it will be moves like this and move, and in a projectile path it will be travel and finally it reaches to the earth, right? Whatever may be the not depending on the path, it will be finally reaches into the its own earth, right? So why it will be happens? Why this thing will be happens? This was wondering so much of time in the aspect of scientists. They are thinking that more and more about this. Why this will be happens? So finally one of the scientists named as Aristotle named as Aristotle find that the stone or maybe that object, the stone belongs to the particular that earth only. Yeah, particular that earth only. So that it will be returns back. He proposed it like that. In the same way, whether if I take a moon is also belongs to the sky. So that it was permanent at there. Many times it will be appears there only. Clear? He proposed that. So because of their belongingness, it will be at that positions, right? That objects at their own positions. Clear? Then now, after a long time, after time will be going on, then these thing will be processed, and these scientists are thinking about those. Scientists are thinking about these, and again they decided that again in the field there is another scientist came into the field, that is Newton. Newton proposed another thing, that is, no, there is a force. There is a force in the field that will gives attraction. That is the attraction force. So because of this attraction force, any object, whatever may be the object, thrown into the sky, it will be back again. So these force of attraction gives whatever may be the object we thrown into the sky, it gives some acceleration on this particular object, so that only it will be again reaches into the earth. This thing will be happens at everywhere, whether it is, I already said, all this will be happens at the time of earth. We are discussing still now about the earth. So if I am at the moon, so if I thrown any object, if I am at the moon here, if I thrown any object, then there is also, then it also went into some height, then again it will be returns back. Here, then it will also returns. So why? Because of the force of attraction of moon, force of attraction of moon, the particular object will be come back. Same thing, whatever may be, either it is on the based on the sun or wherever it may be. If we thrown any object, then it will be back into the particular place, belong to that particular field. Clear? Why? So by this observation and by the thought process of Newton, he proposes the concept of force, force of attraction. Because of this force of attraction, any object which is which is sent, which is thrown into the sky, which is thrown into upward direction, then it will be returns into the same place. Clear? It will be returns. What is thrown into the sky, then it will be returns. Clear? So, so this force of attraction is universally common at everywhere. This force of attraction is universally common at everywhere. Whatever may be the body, at whatever may be the place, this force of attraction is common between any two objects. Between any two objects. Yeah. This force of attraction is acts between any objects, whatever may be the object given. But it will be happens at yeah, between any objects, whatever may be the object. But the force of attraction is common. Clear? Here is the also force of attraction. Here is also force of attraction. At everywhere, the force of attraction is common. So these force of attraction will be happens until the entire universe. Clear? Until the entire force of attraction is common at the until the universe. So then this is applicable at everywhere. That is either maybe between the some terrestrial bodies, between the terrestrial between the terrestrial bodies, terrestrial, between the terrestrial bodies, or maybe between the celestial bodies, or maybe between the celestial bodies. So wherever it may be. Okay. So what is this terrestrial bodies? Already we know that these terrestrial bodies means like a small objects, whether like a stone or like maybe a or like maybe a pebble or maybe like may some small, very teeny particles, very small objects. Okay, these celestial bodies is a big objects, which is we can see in our space, like the moon is one of the celestial body. It's a large body, and the asteroids is also very large body. Yeah, and the asteroids and the biggest satellites. So all those are celestial bodies. Already you know about that. I'm just reminding you. So whatever may be the terrestrial bodies and celestial body follows these physical law. Yes, these physical law. That is nothing but a force of attraction. Clear? This is now force of attraction. So basically, these force can be categorized into four categories based on their nature and based on their strength. Clear? Strength of the force. So let's we discuss what are those. First one. So based on the nature of the force and the strength of the force, the four forces are: first one, gravitational force, gravitational force. Second one, electromagnetic force, electromagnetic force. Third one, strong nuclear force. Fourth one, weak nuclear force. Okay. According to the nature and according to the strength of the forces, there is four type of forces is there. The force will be categorized into four types. Okay. So those are gravitational force, electromagnetic force, and strong nuclear force and weak nuclear force. Let's we now our topic today is now let's we discuss about the gravitational force. This is our main topic today. Gravitational force. Yeah, this is our topic today. So what is this gravitational force? So what is this gravitational force? Yes, this gravitational force is the completely responsible, is only the responsible for the force between force between two particles of a particular body. Force between two particles of a particular body which have certain masses. Yeah, this gravitational force is a responsible between the two bodies of a particular two bodies which having a some mass, or this force is responsible. The force of attraction acts between the particular two particles of a body, of an entire body. Sorry, once again, of an entire body which have masses m1. This like m2. Some else. I just given some names m1 and m2. So and also whatever may be, this force is responsible between the force of attraction. This force is responsible between the attraction between the two bodies which have a particularly some mass. Clear? This is about the gravitational force. This is the responsible force for the action of attraction between the two bodies, or between the two particles of a bodies, two particles of a body which have a some masses, right? And similarly, this gravitational force is very weak force. Yeah, this gravitational force is very weak force. Why I said, let's we discuss why it is a weak force. And first, I am explaining the characteristics. This is a very weak force. Second one, this is a very strong range force. And third one, this is charge independent. It is a charge independent. And fourth one, it does not depend on nature of the object. Does not depend. I will clear it. It does not. It is independent. Independent on nature of object. On nature of object. On nature of object. Next, okay. Next, fifth one. On nature on object. And nature of object and the gravitational forces, long range forces. Sorry, I told you some wrong there. This is not a strong range force, it's a long range force. Just a second. This is a long range force. This is a long range force. Here is a long range force. So this is a very long range force and a charge independent, and does not depend on the path traversed, does not depend on, does not, and maybe I'm not possible to write easily on this board. It does not depend on, does not depend on path traversed. The path traversed, on which path it is traversed, it does not depend on. At everywhere it will be attracts. Okay, and it is always attractive force and charge independent, which is gravitational force is a universal in nature. Gravitational force is universal in nature, universal in nature. Yeah, which is universal in nature. And one thing, the more important thing, important point, that is this: the force, the gravitational force acting between two bodies is always dependent on, is always dependent on the product of two, the product of mass of two bodies of two bodies and also depend on the distance, the square of distance between the square of distance between the square of distance between the two objects. Here, distance between the two bodies. Between the two bodies. Here, that is, this F is, force is always depend on the product of masses of the two bodies and also depends on the distance or distance between the two bodies. This is the two mass one. This is the body mass with m1. This is the body which have a mass with m1, and this is another body which have a mass m2. So the force between these two, the force acting between these two was completely depend on the product of these two masses and the distance between the two objects. I will clearly explain you how it is. So, for example, this force is completely depend on the two bodies. This force is depend on masses of the two bodies. That is the force. Simply also, simple better. Simply, I will explain you. This force is depend the force between these two bodies. Between these two bodies is completely depend on the mass, the product of the mass of the two bodies, and the distance between the two bodies. The distance between the two bodies. That is, F is depends on M1, M2, and R also. Clear? Next. So basing on this concept, Newton proposed a Newton law of gravitation. Newton law of gravitation. Newton proposed a Newton law of gravitation, which is a famous for the Newton law of gravitation. According to this thing, Newton law of gravitation, every particle in the universe should be attract other particle with a force, with some force. So that force with some force, that force is directly proportional to the mass of the two, directly proportional to the product of masses, and also is inversely proportional to the distance, square of distance between the two particles. Once again, in the universe, wherever the place in the universe, each and every particle attracts the other particle, with some force. That force is directly proportional to the product of these two bodies, the product of the two masses of the particles, the product of two masses of a particular particles. Okay, the product of two masses of a particular particles, and also it is indirectly proportional to the distance between the particles. That is the square of the distance of the particles. That is just clear. I'm clearing that. The force which is acting, between the two particles, acting between the two particles is directly proportional to the product of two masses of a particles and is indirectly proportional to the square of the distance between the particles. The distance between the particles is r, its square is r square. Clear? So what he stated that F is directly proportional to the m1 m2 by r square. Here, this force, the particle with the mass m1 is acting with the force F12 on the particle which having a mass m2. Clear? For example, this is a particle A, this is a particle B. This particle A gives some attraction force, applies some attraction force F12 on particle B. Why? Because I said I'm thinking that this is a particle 1, this is a particle 2. For example, and the particle 2 gives also applies some attraction force on particle 1, that is F21. So each other, they can attract each other. They can mutually transfer their forces, mutually attracts each other with some forces. Whatever maybe, if that is F12 or F21, whatever maybe, it is a force. Clear? So that force is directly proportional to the product of the two masses and is also indirectly proportional to the square of the distance between the two particles. So we know that. Then to equalize the equation, so I am introducing another constant, that is G. G is nothing but a universal gravitational constant. Universal gravitational constant. Universal gravitational constant. So by introducing this gravitational force, gravitational constant, then I put equal to, so instead of proportionality, that is F equal to G into M1 M2 M1 M2 by R square. Clear? So this is the force particularly acting between these two particles. This is the force. This is the force. Once again, I will. Yes, this is the force. Equal correct. Acting. This is a force acting between these two particles. What is that force? That is F is G into M1 M2 by R square. That is nothing but its force. So this force is acts between these two particles, these one and two particles. That is G M1 M2 by R square. Okay. So this G is a, already we know that, gravitational constant. So according to this equation, we can define F equal to G M1 M2 by R square. That still we control that. That is equation number 1. By this, G equal to, we got F R square by, this R square will be moving to this side, F R square by M1 M2. Yeah. So by this, we can define the G value of G is F R square by M1 and M2. And the units of this universal gravitational constant G is already here. We know that in MK system, I am telling that the units of gravitational constant, that is Newton meter square per kg square. Clear? And in FPS in CGS system, dyne centimeter square per gram square. Clear? So this is about G. Clear? Then now, so this G is universally common and constant at everywhere. Clear? And it is always acts on same on any particle and it does not depend upon any medium. It does not depend upon any medium. Clear? It's a very important point. It does not depend upon any medium. It works at anywhere, whether there is a medium or not, but it works. So that only entire the universe will be exist. Clearness. So still now we discuss about G, that is universal gravitational constant. Now, what about the individual gravitation? So this gravitation is at everywhere, whatever it may be at the sun, or it may be the moon, or it may be at the gigantic stars, or it may be the wherever it may be. Wherever you go in the universe, this G is common. Still now we discuss regarding for all, common thing for all. But what about the individuality? For example, I want to discuss about the gravitation of the Earth. So this Earth also gives a particular gravitation on a specific bodies. So gravitation force on a specific bodies. Because of this gravitation force, the acceleration will be occurs acceleration will be occurs on the bodies, right? Acceleration will be acts on the bodies. So how we define this? So let's we discuss about acceleration due to gravity. Acceleration. Acceleration due to gravity. Because of gravity, how the acceleration will be happens. For example, considering that Earth is some isolated body, so which will gives some attraction force on the particular body, either maybe it is stone, for example, on the stone. So what is this force? What is the magnitude of this force is F is mg. Here m is the mass of the stone and g is the gravitation. So considering Earth is an isolated mass, a force is experienced by a body near it. So at the Earth, near the Earth, there is some force is experienced. There is some force is experienced by the Earth. This force is always directed. This force is always directed towards the center of the Earth. Clear? Or toward the center of the earth and has a magnitude. So this has a magnitude that is mg. Mg is the magnitude F equal to mg. And g is the mg. M is the mass of the body and g is the gravity. So gravitation. So by both product, the entire force acts by this particular earth is mg. So finally, F equal to mg is the force act by the particular body what we taken, either it may be the earth or it may be the moon, whatever may be. This G will be changes. Clear? This, for example, this G will be depends on the what the body we taken. At the earth, it is 9.8 meter per second, and in the same way, in the moon, it will be changes. So this G will be changes. According to this G, product of and mass will be common. So according to this, the entire this force will be changes. Clear? Are you understand? So for example, this force, whatever may be, if I taken a some big stone, if I taken a big stone, then this stone, the force of this stone is depends on this G, depends on this product. Okay, the product, this force will be change at this earth, and this force will be changed at the moon. Different. So finally, this how this different as this force equal to mg. Here mg is a magnitude of the particular force. Okay, this force is directed towards center of the earth and has a magnitude that is mg. So similarly, finally we got F equal to mg is the force. This is equation number 2. By the equation number 1, already we have equation number 1, F equal to G into m1 m2 by r square, right? So by equalizing with these two, G m1 m2 by r square equal to mg. Clear? And for the case 1, I taken F is a isolated body here. In that case, for the mass m1, considering the Earth's mass, it is very high, right? It's a very big object. So there's a some celestial body, right? So it's a very big object. So that that object, that mass will be m1 is, I've taken that mass is because it's a very big, so that I taken that is a capital M. Here the first object that is m1, that is the Earth. That mass will be very big, so that I taken the capital M as the value of m1, which is belongs to the mass of the Earth. Similarly, I taken this for the m2. Again, I taken the for testing. I taken the stone. The stone is comparatively very less mass comparative to this Earth. So that same that will be mass small m. Clear? This is capital M. This is small m. So I put these conditions, and in the same way, the distance of the object, the distance between the distance r. That means the stone is just on the just layer on the earth. So that means it is the distance between the center to the earth is very high. So it will be indicated with a r, so that I can be indicate this r will be taken as capital R just for identification. Clear? Why? Because those are very big. That's it. That's only. Okay.